Hi everyone, and welcome to week 4. This week we're covering some of the most essential skills for a system administrator: maintaining storage. We're going to walk through the entire process of adding a new virtual disk to our system, creating a partition, formatting with a file system, and making sure it's available for use every time the system boots. We'll also have a brief introduction to System D. The service manager will be exploring more next week. Let's get started. The first thing we need to do after adding our new virtual disk is to identify it. The command lsblk for list block devices shows us all the disks and partitions attached to the system. We can identify our main OS disk, NVMe 0N2, by its larger 40 gigabyte size and its existing partitions. The other disk, NVMe 0N1, is our new 2 gigabyte disk. Notice it doesn't have any partitions under it. A quick note: your device names might be slightly different, like SDA or VDA, depending on your system, and that's perfectly normal. The process is the same. To create a partition, we'll use a classic and powerful tool called fdisk. I'll run sudo fdisk/dev NVMe 0N1 to start working on our new disk. We're now inside the fdisk utility. The first step is to create a new partition. I'll press N for new. It's asking what type of partition. We'll choose P for primary. Now it's asking for the partition number and the start and end sectors. For this lab, we want the partition to use the whole disk, so we can just accept the defaults by pressing Enter for each one. The final and most important step in fdisk is to write the changes to the disk. Nothing we've done so far is permanent until we press W to write the new partition table and exit. The system will tell us the partition table has been altered. Now, if we run lsblk again, you can see our change. Our NVMe 0N1 now has a partition under it called NVMe 0N1 P1. Now that we have a partition, we need to format it with a file system so the operating system can store data on it. We'll use the standard Linux file system, ext4. The command is mkfs.ext4 for makefilesystem.ext4, followed by the name of our partition. So this will require administrative privileges, so sudo mkfs makefilesystem.ext4 /dev /NVMe 0N1 P1. The system will create a file system and gives us a confirmation message. Before we can use our new file system, we need to attach it to our main directory tree. The location where we attach it is called a mount point. A mount point is just an empty directory. I'll create one now at the root of the file system called /data using mkdir. So sudo mkdir /data. To attach our file system to this mount point, we use the mount command. The syntax is mount device space mount point. So sudo mount dev nvme 0 n1 p1 to the mount point of /data. To verify that it's mounted, we can use the df -h command, which stands for disk-free human readable. And you can see right at the bottom our new file system is mounted on /data and available for use. The problem is this mount is temporary. If we reboot, it'll be gone. To make it permanent, we need to add an entry to a special file called etc fstab, or the file system table. I'll open it with vi. Sudo vi /etc/fstab. So I'm going to press I for insert mode. And we need to go and make a new line. So I'll go to the end of the file and add a new line that tells the system what to mount, where to mount it, the file system type, the options to use, and 2 numbers for backup and error checking. We'll just leave as 0. So /dev /nvme 0 n1 p1 /data ext4 defaults 0 0. Notice something that's interesting. Right now, I'm mounting it via the mount point name. However, it is also possible to mount it via the unique identifier. In some ways, using the unique identifier is actually better, because in case this name ever changes, the unique identifier will not. But for this demonstration, we're just going to use the mount point name. Now I'll save and quit. In vi escape right quit. Now for the ultimate test. To be absolutely sure our fstab entry is correct, I'm going to reboot the machine. If our entry is right, the /data directory should still be mounted when the system comes back in. Okay, we're back up. Now I'll run df -h one last time. And there it is. Our /dev /nvme 0n1 p1 file system is still mounted on /data. That means our fstab entry worked perfectly. Now, for our final topic this week, a brief introduction to systemd. We've just seen how fstab is a configuration file that the system reads during the boot process. The program that actually reads that file and does the work of mounting our file system is called systemd. Systemd is the core service manager for almost all modern Linux distributions. It's the very first process that starts after the kernel loads, and it's responsible for starting all the other services and processes that make the system run, like networking, the graphical user interface, and the web server we'll install next week. We'll be working with systemd a lot more in week 5, but for now, just know that it's the manager that runs in the background and brings your system to life. And that's a complete walkthrough of adding a new disk to a Linux system. We've partitioned it, formatted it, and mounted it permanently. Be sure to practice these steps in this week's lab. As always, if you have any questions, post them in the Q&A forum. Thanks for watching.